It's our closest planetary neighbor, referred to as Earth's twin, and the brightest planet in the solar system. And yet, interest in Venus has been limited until quite recently. The discovery of a chemical compound in the atmosphere of Venus has many looking towards the sky and speculating anew about life beyond Earth. Dr. Shannon Schmoll is the director of the Abrams Planetarium at Michigan State University. She's an expert in astronomy, eclipses, constellations, and the night sky, and we're so happy that you could join us today.
Thanks for having me. I'm happy to be here.
This is a significant development. What was the chemical compound detected in Venus's atmosphere, and why does it matter?
So the compound is called phosphine. So it's one phosphorus atom and 3 hydrogens. So it's pH3 if you want to know the chemical symbol there. But it's called phosphine, and this is a gas that quite recently has been suggested as a biosignature. So suggesting that if we find this gas on other rocky planets like the Earth, especially those around other stars, it could be an indicator of life. So other ones that we've looked at before, oxygen and methane, those have come up quite a bit, but we don't have a lot of other biosignatures. So this one's been suggested as a possible biosignature since most rocky planets like the Earth are not going to be able to make it on their own without biology or some other means, like on Earth, for instance, we make it through human intervention or through microbes on Earth will create it. So that's why it's being suggested as a biosignature.
The discovery was quite unexpected because of the hellish environment, but the chemical was detected in the clouds, not on the surface. Has it ever been detected before beyond Earth?
It has been detected beyond Earth before, notably on the planet Jupiter. So Jupiter is a big gas planet. It doesn't really have a solid surface, but it still has really high temperatures and pressures in its layers of its atmosphere. And so it has been found there, and it can be explained as being formed under those conditions, basically. But Venus doesn't have those conditions. And so we haven't detected it on Venus before. We have found it again on Earth, either through man-made means or through microbes. So the fact that we're finding it on Venus is really exciting. It's not something that we've really seen before, and it was detected twice with two different telescopes in the same concentration. So that helps us show that this is real and not something that perhaps is a mistake in the data. So this is really exciting. We don't expect to find a lot of phosphine in the atmosphere, but yeah, it was found within sort of a middle layer of the atmosphere where the temperature is around 30 degrees Celsius, which is about 86 degrees Fahrenheit. So it's much more Earth-like. For reference, the surface of Venus is about 900 degrees. So not very pleasant at all. So it was found in this more Earth-like temperature range, but it's still a very acidic atmosphere. And so it's kind of strange to find something there.
I think when we think of life in space, our minds automatically go to aliens. But what is the reality of what we can expect from signals of life outside of Earth?
Most likely, like if this is life, we cannot say for sure that this is life on Venus, but if it is life, it's going to be microbial life. And generally, that's what we're trying to find at the moment is microbial life, bacteria, single-cell organisms that might be exhaling this gas or releasing this gas in some way. And so it's unlikely that we're finding intelligent life. We're not going to be finding other aliens like us, like humans, but we will be finding sort of these little starting points of life, these single-celled organisms that have the potential to eventually evolve into something else.
Which makes it significant in itself.
Yeah. So this is, I think one of the things about humans is that we always want to know where we came from. We're always trying to answer that question. And so trying to find microbes elsewhere, we know that life started on Earth as a microbe, and here we are today. And so finding that elsewhere makes it really significant because it suggests that life is maybe a bit more easily found than we thought before. And this is a concentration in a lot of what we do. It's what we're trying to do with Mars. Enceladus and Europa, which are moons around Jupiter and Saturn, are really interesting now for the same reason. We think that there might be liquid water underneath their surfaces, so there's potential for life there. And so it's always this sort of driving question: where did we come from, and how can we see that happening elsewhere?
Fascinating. We know very, very little about Venus compared to our knowledge of other planets.
Mhm.
How is this going to affect research and exploration moving forward?
Well, I think we're going to have definitely a bigger interest in the planet Venus moving forward. Certainly with the more Earth-based telescopes, we'll probably be focusing them towards the planet a little bit more often now to confirm this phosphine gas, to understand where it could be coming from more, to see, is it life? Is it something else that we didn't understand before? Either way, there's really fantastic questions coming out of this. Is this a new chemical reaction that we didn't know about before? Or is this life? Either way, we've got some questions to answer ahead of us. But on top of that, NASA is planning on sending a new spacecraft to Venus in the coming years, a new mission. There's currently, I think, two in the pipeline where NASA is going to choose between one or the other. And so that was planned before this, but I think that's going to make this mission a little bit more exciting in the long run.
Is it because of the brutal inhospitability of the planet that it's largely unexplored? And moving forward, what might that exploration look like?
So we haven't done a ton of exploration of Venus, largely because it is inhospitable. So the Russians in particular, starting in the 60s and through about the 80s, have sent several landers to the planet, and they have landed on the surface and sent back information. But the first one lasted about 50 minutes, and the last one lasted about 127. And that's because it's so hot on Venus. The atmosphere is a lot of sulfuric acid. It's not very hospitable. And so landing is possible, and we might want to do that, but I think there's also going to be a lot of interest in the atmosphere. So a previous mission to Venus from NASA was an orbiter that sent probes through the atmosphere at different points and gathered data and sent that back. So I think we'll see some of that. Our technology is also changing, that we can go into orbit and look through the atmosphere and study it while in orbit, and that might be the safer and longer term ability to study. So that's what exploration is really going to look like. Potentially some things going through the atmosphere to get more data, landing, but also orbiters that can last a lot longer than anything that goes through those clouds.
Well, with every space agency eyeing our long neglected neighbor, Venus is sure to get some attention over the next several decades. Dr. Schmoll, thank you so much for a down-to-earth look at the planet that lives next door.
Yes, thanks for having me.